Next in our notes for 8.2 is we are going to tackle some problems that are pretty popular and demonstrate a lot of knowledge of rectangles. So sketch a parallelogram that is not a rectangle actually does make sure that you know what a rectangle property is. So they want us to focus specifically now on the 4 interior angle measurements. So really simple. Sketch a parallelogram. It's not about what it looks like. It's more about the measurements that you use. Okay. So we just want the interior angle measurements. We don't have need any other marks. What we could do is choose a angle measurement. Let's try something that's above 90, obtuse. And what we can show over here is either that this is 72 degrees, one way or another. Show it that way or show it this way. That's demonstrating the consecutive angles need to add to 180. Now, we could put 108 here and 72 here. That's obeying the rule of opposite angles have to be congruent in a parallelogram. So that's using all the rules of interior angles, and it's making sure it's not a rectangle. If it was a rectangle, they'd all be 90. All right. So this time so this is the second situation. We want a rectangle that is, the parallelogram that is a rectangle, so just throw a 90 in there. Okay, so 4 right angles. That's all they require. And that's going to work for number 2. Sketch a parallelogram that's not a rectangle. Let's see, draw the diagonals. This time they want the diagonals. They want the measurements of the segments formed by the intersection of the diagonal. So what they want on this question is for us to basically show we know the diagonals must bisect each other. So we'll call this 12. So then that's 12, so that those are the same. You can even mark it. Okay, these are going to be the same, so let's make those 9. And now that's evidence that we have a parallelogram, but not a rectangle. All right. This is the one that's not as commonly known. When you have a rectangle, the diagonals will cross in the center, and all 4 of these segments created by the diagonals intersecting, all 4 of those are congruent. So we will make them all 9. Okay, so that's what they're looking for in that one. Sketch a rectangle that's not a square. Okay, so this one's different. All right. So you're thinking a rectangle, it can't be a square. Yes, it can. Okay, if I have a rectangle, what I could have is side measures that are like this, right? So this is a rectangle that's not a square, okay? But there's no rule against a rectangle having, just so happens that it is a square. There is no rule against that. These could all be 8s, and you could still consider this a rectangle. It's also a square. It's an upgraded rectangle. It's better than a rectangle, but it still is a rectangle. It's got 4 right angles. So when a rectangle does have 4 right congruent sides, it's a square. Now we want to make sure that we sketch a rectangle that's not a square. So we want the length and the width to be different. Now what does that mean for the diagonals? Okay, so when we have the diagonals crossing, we know that the diagonals have to be congruent. Okay, so there's a few things that happen on this. Because these are the same, okay, what would end up happening is you would have isosceles triangles in here. So what we're looking at from here to here is 30, then that's going to be the same. Now, what's going to be a little different is these would have to be 60. Why? Because the 2 angles together have to add to 90. Okay. Now, again, since we have all these diagonals are congruent, we have a bunch of isosceles triangles going on here. So here's all the angle measurements. Oops, that's 60, I apologize. Not 30. 30 is up top. Okay, so what we have is all those angle measurements. And if you go 30 plus 30 is 60. 180 minus 60 is 120. So what I'm calculating right now is that. So that's 120, so that. Okay, so what it asked for was all the angles basically on either side of the diagonals, including the intersection. So they wanted all the angles created by the diagonal. So a couple of ideas there. Think diagonal, and then create isosceles triangle in a rectangle. All right, so that could be a problem. They have, worked on something like that in their regions